right, hey guys. So during the last video, we watched the transactions and the timestamp server, which is actually super interesting because since it's Bitcoin is money, then it needs to be transacted. And we kind of reviewed everything about the transactions. Now we're going to take a look at the proof of work, which is super important. So what Satoshi is explaining here is that to implement a distributed timestamp server on a peer-to-peer basis, we'll need to use proof of work system similar to Adam Back's Hashcash, rather than the newspaper or Usenet posts. So essentially what it's saying here is that there have been multiple attempts in the past to create some digital money, and it's not that it failed, it's that it wasn't complete like Bitcoin is, right? Um, at least close to uh, production. And basically, the Hashcash was the same thing as Bitcoin on a peer to peer. However, it was not peer to peer, it was on a server, on a computer. Um, so you could easily shut it down, and that's exactly what happened. Um, So the proof of work involves scanning for a value that, when hashed, such as with SHA-256, the hash begins with a number of 0 bits. The average work required is exponential in the number of 0 bits required and can be verified by executing a single hash. It's kind of glancing over the hash algorithm, which is SHA-256, and the difficulty adjustment for the proof of work. Those are very highly technical terms. It simply means that in order for you to be able to transfer value from one individual to another, proof of work is needed to ensure that the value transferred is actually valid. So this is the consensus mechanism here that is kind of oversimplified here. And it's using a digital algorithm that's called SHA-256 to make sure that the transaction is pretty much abiding by the law of mathematics, if I could say it that way. So for our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found that gives the block's hash the required 0 bits. Once the CPU effort has been expended to make it satisfy the proof of work, the block cannot be changed without redoing the work. As later blocks are chained after it, the work to change the block would include redoing all the blocks after it. And this is pretty much the gold behind why this works. Essentially, it's explaining what the process is to implement proof of work. Basically, you add a lot of zeros in front of the block's hash, and that increases the difficulty to hash it. So the miners have to calculate that difficulty in order to get a reward and to include that block in the blockchain. Without that process called proof of work, it's not possible to transfer that value, like any value, from anyone to anyone without being censored. So proof of work is really the heart of how it really works. So you see how we can easily go down the rabbit hole here, because this is an oversimplification. I know it has technical terms, but long story short, one block of transactions is being included into the blockchain by the miners, and the miners have to make a computational process to add it to the blockchain. And it's not as easy, but essentially this whole section is kind of explaining how one block is linked to the other through the hash using a hash algorithm called SHA-256, and each block is linked to the other by the previous hash block. So essentially right here, you see this is one block and this is another block, and you see how they linked with the previous hash, right? So the previous hash, it's this hash right here of this block. It's including in the next block. That's how they link together as a chain using that hash. And every block includes transactions. You see the TX, that's for the transactions. And they are all limited in size. I believe it's 1 megabyte per block. We can view all that a little later as far as like how much space each transaction can take in a block, and essentially miners prioritize the transactions based on the fees, not necessarily based on the size of the transaction. Actually, based on both. But we'll review all of that. So this section is pretty much explaining what the process is and how the proof of work algorithm works by incrementing a nonce, which is a random number, in the block until a value is found that gives the block's hash. So that's not our job, essentially, unless you're a miner. So the proof of work also solves the problem of determining representation in majority decision making. If the majority were based on one IP address, one vote, it could be subverted by anyone able to allocate many IPs. Proof of work is essentially one CPU, one vote. The majority decision is represented by the longest chain, which we already viewed before. The longest chain is the truth, and that's what every node should have to go by and abide by. Those are the rules. So which has the greatest proof of work effort invested in it? In majority of CPU power is controlled. If the majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest and outpace any competing chains. To modify a past block, an attacker would have to redo the proof of work of the block and all blocks after it, and then catch up with and surpass the work of the honest nodes. This is gold, y'all. This is really the heart of everything. This is the reason why this is unattackable. I shouldn't say unattackable, but more like it builds within itself because of the decentralization of the hashing rates and the hashing power of every node. So every node is contributing to the consensus here of the proof of work mechanism. So basically, right now, to kind of make it simple, you go through a website and then you add, you use your computer to reach a web page, and you can basically either reach the web page or not. To make it simple, if the web administrator decides to like shut it down, then you can't reach the page, right? But with Bitcoin, you basically have all these nodes spread out, so there's no center point of failure. Like you can't just shut it down because the transactions are being replicated on all nodes every single time, and nobody can. If one node wants to censor a transaction, they can't do it because the transaction has already been replicated and has already been picked up by a miner, and that miner is already accomplishing proof of work because he has an incentive to get some rewards. He needs to get some rewards. He's trying to get some rewards. So he will have to be forced to be honest and play along with the rules of the consensus, because that transaction needs to be validated by everyone to be accepted into the blockchain, um, and propagated by, to all nodes. That's pretty much what it is. So there's no single point of failure here. That's what this whole proof of work is pretty much the basis of. It's this is how the transactions are being propagated from one party to the other, like one node, one computer to the other. It's kind of explaining that the goal here is to remove center points of failure. So it's talking about IP addresses because the whole Bitcoin network doesn't take into consideration your IP address. Doesn't take into consideration anything that we are used to, and that's the beauty of it right now. So I hope that this kind of summarizes everything as far as proof of work. It's a very deep concept to kind of explain in a few lines right here. But essentially, if there's anything to remember here, is that the proof of work, it's an algorithm that is made for miners to make sure that those transactions are being confirmed and validated properly, without any intermediaries. This is the whole heart of it. So no one will be able to get in between any transaction, because there's no single point of failure. There's no IP address collected. There's no name collected. There's no email address collected. There's no phone number being collected. Those transactions are being routed, and the value is being transferred from one party to the other, from one hand to the other, like cash, one hand to the other, using a digital algorithm and a consensus mechanism called proof of work. Just like those images are kind of showing right there, from one block to the other, retaining the previous hash every single time. That's pretty much all there is as far as proof of work. And of course, I really invite everyone to review the bitcoin.org webpage. If there's any questions, it explains everything. And don't forget, lob.net is the web page, the website to go if you have any doubts or any clarifications. You can just double check everything over there, get clarification on everything. This is a fast evolving revolution, I would say, that Bitcoin represents. So the proof of work is really, really, really important to understand. So I hope this has been informative for you. I hope you understand what the proof of work algorithm is on its own. And yep, that's been it. So thank you, and I'll see you next time. Bye-bye.